then we have definition of continuous function. Now you can see. Let n be defined on open interval AB. Any actual belongs to the open interval AB. The function f is said to be continuous at x0 if the limit of function f at x tends to x0 is equal to the value of function f at x0. In such case, x0 is called a point of continuity. Continuous tiếp tục và tiếp không theo gọi là tiếp tục. To continue, if n is not continuous at x0, it is said to be discontinuous at x0. In such case, x0 is said to be a point of discontinuity. The finally, f is continuous on open interval AB if and only if f is continuous for all f belonging to open interval AB. Definition related to continuity and discontinuity of function. Okay, now how to check the function f continuous at x0 with way on this quality. So we can separate the condition here to the three subparts. Three subconditions. Now we have the property the function f continuous at x0 if and only three subconditions satisfied. The first f well defined at x0 well defined. Well defined is that means you can estimate the value f at x0 well defined. To continue, the limit fx when x tends to x0. The limit here exists. So finally, the limit here is equal to the value function f at x0. The limit fx when x tends to x0 is equal to x0. Okay. Three subconditions. To check the function f continuous at x0 or not. If one of three subconditions here don't satisfy f discontinuous at x0, you can see f I and m is actually if and only if. Okay. Now let me give you an example. We consider the function fx equal x squared, x0 equal 1. Now we want to check the function f continuous at x0 equal 1 or not. I think we need to check three subconditions here. Now, the first, do you think the function f verified at x0 equal 1? Verified? Yes. You can estimate the value function f at x0 equal 1. What value? What value? 1. Verified. To continue, we check the limit of function f when x tends to x0. I think that's very easy to see. When x tends to x0 equal 1, we have the value function f tend to 1 squared equal 1. Okay? I think we can very easy to check the limit the limit mx when x tends to 1 is equal to the limit x squared when x tends to 1 is f1. F1. So finally, we check two values here if f or not. F or not. Okay. Okay, from two conditions here, we can find the limit fx x tends to 1 is f4, f1. So, therefore, f continuous at x0, f1. Okay, we can check. We can check the function. Continuous at x0. To continue, we have another example. Example. We have the function fx is equals sin x over x. x0 is equals 0. Now, what do you think about the point x0? The function f continuous or discontinuous at x0? No. Why? The condition here don't satisfy. Okay, you can see the function f is equals sin x over x. The function here not satisfied at x equals 0. Okay. So this condition does satisfy. Yeah, does satisfy. So x0 equals 0. This continuity. Okay? A point of this continuity of function. So finally, it's mentioned to the as continuous on open interval. Very easy to see the function here. Continuous on 1, 2. Yeah, I think you can check three conditions here for all x0 below. Yeah. So the function f equals x squared. Continuous on open interval 1, 2. The same. 0%. Okay? That's it. To continue, when we consider definition of continuity and discontinuity, it gets into the existence of the limit x tends to x0. I think you know x tends to x0 is that mean x tends to x0 the one side. The one side. Sometimes we only consider the limit here when x tends to x0 from the left or right hand side. Okay? When x tends to x0 from the left or right hand side, we have the continuous from the one side. Okay? It is here we consider the limits when x tends to x0 from the right hand side. We have the continuous from the right. The same, we have the continuous from the left. Okay? Okay. If the function f continuous from the right at x0, sometimes we go at the right hand continuous at x0, the same. Okay? Okay, now let me give you an example. We consider the function f, and the formula is f of x is and less than 0. is equal as square plus 1 if the x greater than 0. We consider the point x0 equal 0. Now, we want to check the function f continuous at 0 or not. The function f continuous from the one side or not. Okay? Now, 5. Okay, now first of all, we need to check the function f continuous at x0 equal 0 or not. How to check? How to check the function f continuous at a point? Okay, I think we check the 3 subconditions here. Verify the limit exists. True value here is equal. Now, check 3 subconditions. The first, verify x0 is equal to 0. You can see 0, it belongs to this one. Okay, it belongs to this path. So, we can estimate x0 is equal because 0 is belongs to this path. So we can use the formula. We use the formula to estimate the value function f at x0. So the value here is equal 1. Okay, equal 1. Is that mean f defined at 0. The first subcondition verified. To continue, we want to check the limit here is it or not. What happens if the x tends to x0? Unfortunately, when x tends to 0, left or right, the function f has the different formula. X tends to the left, we have the fx is equal. From the line right, we have fx is equal. So if you want to check the limit here, is it or not, we need to check the one side limit, is it or not, when x tends to 0. The limit? What's the limit? What's the limit? The limit fx when x tends to 1 plus what value? I'm sorry, 0 plus what value? X tends to 0 plus is that mean x tends to 0 from the right hand side. Is that mean x tends to 0, x greater than 0. X greater than 0 is that mean we use the formula for f. Yeah. So the limit here is equal to the limit x tends to 0 plus fx, okay, x squared. Plus 1, the value here is equal 1. Equal 1. Okay, x tends to 0 plus, we can denote this by? We can denote this by? So, 1 is exactly the same. To continue, we want to estimate the left-hand limit. X tends to 0 minus what value?
0.
x tend to 0 minus, is that mean x tend to 0 from the left hand side? Is that mean x tend to 0 at less than 0? Okay? So we can use fx equal x, okay, to estimate the left hand limit. Is equal to the limit x tend to 0 minus x. Okay, here is equal to 0. So finally, if the limit here is 0 not? No. Okay, two one side limit is not equal. So the limit doesn't exist. Doesn't exist. The limit here doesn't exist. Is that mean the function f is continuous at x0. Okay? The first f is continuous at x0 and x0. To continue, f continuous from the right or not?
Yes.
F continuous from the right or not?
Yes.
Does that mean we can check two values here if f or not?
Yes.
F0 equal 1. F0 plus equal 1. Okay? So the function f continuous from the right. F continuous from the right. At x0 equals 0. So finally, you can check the continuous from the left. If it continuous from the left, from the left is that we need to compare value right, sorry, left limit and value left of x0. We need to compare two values. F0 equal 1. F0 minus equal 0. 0. Two value is not equal. Two value is not equal. So the function f is continuous. And this continuous. This continuous from the left. This continuous from the left. Okay. Based on the example here, we have the property you can see. F continuous at x0. If and only if two one side limit exist, okay, is equal to the value of function f at x0. If and only if. You finish that now? Okay. We continue. Let's introduce some property to get the continuous function. Now, we want to enunciate for continuous function and discontinuous function. We have to graph the function f have this form. We can use black point. Is that means the function f where we find this point. We can use white point. Is that means the function f not verified as point. Okay? You can denote y point. It that means the function f not defined as this point. Black point. It that means the function f defined this point, this value function. Now, consider the now function. We check the x0 equal to. What do you think about the point? Continuity or discontinuity?
Continue.
Continuity. Now, let's see. If you have the x0 equal to this value, it that means the function f verified at x0 equal to. Okay? To continue, we check the limit of function when x tends to x0. You can see the curve continuous. So when x tends to 2, we have the value fx tend to f2. Is that mean x0 equal to a point of continuity. Okay? Now, continue to check the x0 equal 3. What do you think about this point x0 equal 3? Continuous point or discontinuous point? Discontinuous. Why?
That is in the limit.
Now, you check the 3 conditions for continuous. The first, verified. Okay, you can see x0 equal 3. We have the value f3 is equal. So f verified x0 equal 3. To continue, we need to check the limit here is it or not. Now let's see the graph. What's the left hand side? What's the right hand side? Now when x tends to 3 from the left hand side, we have the value of x tend to. The right hand side, okay, we have the value of x tend to. Two values here is not equal. It that means the limit doesn't exist. Okay, you can imply the function f is continuous at x0 equal 3. Okay, it that means x0 equal 3 a point of discontinuity. So finally, we check x0 equal 1. What do you think about?
This.
What do you think about the
Discontinuous.
x0 equal 1? Continuous or discontinuous point?
Discontinuous.
Why?
Is not defined.
X is not.
Not defined.
Okay. Doesn't define an x0 equal 1. Okay. We can denote y point. It that means the function f not defined at x0. So this point is measured to this continuity. Now, continue we measure to the function f continuous on low interval AB. Low interval AB. It's a non-open interval AB. Low interval AB is that means the domain contains two limits of interval. It contains the A and B. Low interval tức là khoảng đóng. Open interval tức là khoảng mở. Closed interval thì chứa cả hai đồng mục và open interval thì không chứa hai đồng mục. Closed interval, open interval. Open interval, closed interval. Open, okay, listen to the ID. Now, you can see the definition related to function f continuous on closed interval AB. F is continuous on closed interval AB if and only if f is continuous on open interval AB and continuous from the right at A and continuous from the left at B. Now, why? Why let's do the continuous from the right at A? You can see f is continuous on closed interval AB. Is that means the domain of function f we consider in this case AB, closed AB. Now we return to the condition for continuity. You can see the limit here exists f tends to f0. F tends to f0, but f it belongs to domain of function. Okay? F belongs to domain of function. What happens if the f0 identical with A? When f0 identical with A, f tends to A, but f belongs to domain. The interval AB we consider f tends to A, f belongs to domain. Does that mean f belongs here? F tends to A? Okay, f tends to A in that case. We listen to the f tends to A from the right hand side. Right hand side. So f continuous on closed interval AB. When we listen to the x0 identical with A, does that mean we listen to continuous from the right? Because f tends to A from the right, not from the left. Okay? Similarly, you listen to the control from the left and B. Because X tends to be only tends to be from the left hand side. Okay? So we have the definition to the function f continuous on closed interval AB. Closed interval AB. Why we separate closed interval AB and open interval AB? You can see f continuous on open interval AB. It means x0 is like between, x0 is not AB. When x0 is like between, x0, x tends to x0, okay, x tends to x0, this may be f tends to x0 from the both side. Both side. Okay, so we don't mention to one side limit. Here, mention to the both side limit. Both side limit. So we need to separate f continuous on open and f continuous closed interval. It's not the same. It's based on the two limits A and B. Okay, to continue, we have some definitions related to point discontinuity. We need to classify this continuity of function. We have the definition. Let x0 a point of discontinuity of function f. X0 is equal to some discontinuity. Somehow we call some discontinuous point the same. Discontinuous point the same. If z exists, the finite limit, one side limit, okay, left hand or right hand limit. Finite hữu hạn, nếu tồn tại hữu hạn, finite hữu hạn. To continue, it must do the definition related to removal discontinuity. Removal discontinuity. If two one-sided equal, and finite. So finally, it must do the infinite, sometimes we call essential discontinuity. That means at least one or two. Doesn't exist infinite là một, finite là vô hạn. Some discontinuous one, removable discontinuous one, infinite discontinuous one. This means we classify the point discontinuity into three types. Okay? Three types. Three types. The first, it has to do the some discontinuous point. The second, removable discontinuous point. The finally, it has to do the infinite essential discontinuous point. Three types. Sometimes we call the first type, the second type, and final third type. Yes? Chia cái liên tục là làm ba loại. Một là ấn điểm, gián đoạn. Loại một gọi là some discontinuous. Loại hai là điểm gián đoạn có thể chuyển đi được, có thể bỏ đi được. Và loại thứ ba là điểm gián đoạn cốt yếu, essential là cốt yếu, còn infinite là vô cùng. Có ba loại điểm gián đoạn. Okay. Now, we return to the example. X0 equals 0. X0 equals 0. I think you know X0, a pointed discontinuity. Okay? To continue, we want to know X0 equals 0. It belongs with type. One? Yes, one. You can see two one-sided exit and finite. Okay? Exit and finite. Exit. Right hand image and left hand image exit. Finite. So X0, we consider in the example here some discontinuous one.